In this video, we'll be looking at thermal and electrical analogs. The systems we will be examining are conduction and convection. This video is by Brian Redden, Michael Tam, Heidi Michelle, and Lisa Woods. In heat transfer, there's conduction, which takes place through solids and static fluids, and convection, which takes place through moving fluids. For conduction, convection, and radiation are R equals the thickness of the resistor over the thermal conductivity times the cross-sectional area of the resistor. For convection, R is equal to 1 over H times the cross-sectional area of the resistor. For radiation, we have 1 minus the emissivity of the material over the emissivity of the material times A. The terms that are analogous between electrical and thermal terminology are voltage, which is analogous to temperature difference in Kelvin, amperage, which is equivalent to heat rate, resistance, which is equivalent to thermal resistance, and capacitance, which is equal to rho VCP, the thermal storage term.
To show an example of transforming a conduction-convection problem into an electrical problem, we will be examining a simple wall. The temperature gradient across the wall is represented by the inside temperature versus the air temperature on the outside. The wall is divided up into 3 sections: the drywall, the insulation, and the siding. These can be represented as thermal resistors in a series network. To convert this to an electrical problem, we just changed the temperature gradient over to a voltage source, and all the resistors into just simple electrical resistors. Now this is a very simple example of converting a thermal problem into an electrical problem. To make it a little bit more interesting and useful to people that are better with electrical problems, let's look at a transient problem. The only difference we'd have to make is for each of the temperatures inside the wall, you add a capacitor to represent that temperature. The charge on each capacitor will represent the temperature at each point in Kelvin. So, if you are very good at modeling electrical circuits instead of thermal, this could be a better way to do your homework problems and learn the concept. This is easily transferred over to a two-dimensional problem where you have nodal equations and a set of points. You will just simply model each node as resistors going into it with a capacitor. And whenever you need to model a constant heat rate, you will just model it as an independent amp source. That is all for this video.